So in this video we're going to have a look at expanding some simple two bracket expressions. Now they will look in this form such that you've got x plus a in one bracket times x plus b in another. There might be coefficients, numbers in front of the x's, and we will deal with that in example E, but for the time being let's just focus on if the coefficients are 1 in front of these. Now the method we're going to use is called the FOIL method, and that stands for expanding the first terms, f, the outer terms, so x and b, then the inner terms, x and a, and then the last terms, a and b. FOIL, first, outer, inner, last. I like to call it the smiley face method, because it sort of looks like a smiley face on the side, and it might brighten up your day. But the FOIL method's the formal name for this. So, going off the general expression then, if we expand the first terms, x times x gets us x squared, x times plus b is plus bx, the inner, a times x, ax, and then the last, a times b, ab. And then, because these both have x's, we can generally combine those together to simplify the expression. Now, it looks a little bit more complicated in its general form, but it becomes quite simple if we practice this. So let's have a look then. So 5a says we've got x plus 1 times x plus 2. If we're using the FOIL method, we use x times x, which gets us x squared using our index rule, power of 1, timesing them, 1 plus 1 is 2. The outer, so x times 2 gets us plus 2x. The inner, 1 times x, which gets us plus x, or plus 1x, and plus 1 times plus 2 gets us plus 2. So we've expanded it, and you should always expect if there's a 2-term bracket times a 2-term bracket, 2 times 2 is 4, so we should have 4 terms here, but then we can simplify them. If we collect our like terms, we can say we have x squared plus 2x and 3x, 2x and x becomes 3x, plus the 2 there, so we get x squared plus 3x plus 2. Moving on to b then, start off in the same idea, so we go with the FOIL method. The first term, x times x, is x squared. The outer term, so x times 2, is plus 2x. The inner terms, minus 2 times x, is minus 2x. And then the last terms, minus 2 times plus 2, minus 4. Now, this time when we collect our like terms to simplify the expression, we've got a plus 2x and a minus 2x. So they're going to cancel. So all we're going to be left with is x squared minus 4. Moving on to c then. Same process, but this time we have a coefficient in front of the second x term, but we tackle it in the same way. If we multiply the first expression, we have x times 2x, which gets us 2x squared. Then we go for the outer, so x times minus 1, which is minus x. The inner, plus 3 times 2x, which is plus 6x. And then the last terms, plus 3 times minus 1, minus 3. If we collect our like terms together, we have 2x squared minus x plus 6x is plus 5x minus 3 at the end. Now, d looks a little bit different because we've got an x minus 1 all squared, and you've got to recognise what this means. If you have a number squared or an expression squared, it just means the thing that you've got times itself. So in this case, this really means that we have x minus 1 times x minus 1. And at that stage, we just do the same process as with the earlier examples. So using the FOIL, we have x times x, which is x squared. Then we have our outer, so x times minus 1, which is minus x. the inner minus 1 times x, which is also minus x, and then the last term is minus 1 times minus 1 plus 1. Collecting our like terms together, we have x squared minus 2x plus 1. Finally, same idea with e as with d. We've got 2x minus 1 all squared. So we can rewrite this as the bracket. So 2x minus 1 times itself. So 2x minus 1. And then we can apply the FOIL method. But this time we've got coefficients in front of both x terms to take care of. 2x times 2x gets us 4x squared. 2x times minus 1 is minus 2x. Minus 1 times 2x is minus 2x. And minus 1 times minus 1 is plus 1. At this stage, just like with the others if we can collect our like terms together. So we have minus 2x and minus 2x there. So ultimately we have 4x squared minus 4x plus 1. Now, you might get to the stage that you can work out from this directly to the final answer, and that's fine, but in the early stages, you need to practice expanding to get all of the terms and then simplifying. And the question might explicitly ask you to show the solution, in which case you want to show the full expansion before you simplify, and that's important. But that's how we can do some simple 2 bracket expansions.